this other question because we did one with exponential growth, I think. There is a question on the test. It's multiple choice, and it'll say, I can't remember which one it says. It either says which one of these graphs is exponential growth or which one of these graphs is exponential decay. So you just have to know the shape. So growth or decay both point up. Decay, and you could draw this anywhere on the graph. I'm just going to sketch a little picture. But it starts big, and then will get small. It will approach an asymptote. The way I just tried to sketch mine, I was trying to use my x-axis as my asymptote, but it's just that general shape that you need to know. All right. This guy, it says, a restaurant offers 8 choices for filling to an omelet. Restaurant allows customers to pick 3 fillings at no charge. How many omelets are possible with no extra charge? All right, so this is going to be like a permutation or a combination. If you put toppings in an omelet, does the order matter? No, because they're all going to go in the omelet. Okay, so is it permutation or combination where the order doesn't matter? Combination. Combination. You guys don't use lockers anymore, but my calc teacher, she always would tell us a locker combination is actually a permutation. But anyway, the order does not matter here. So it's 8. The bigger number, however many you choose from, that has to go first or your calculator won't run this. This is 8, choose 3. Now, you can use graphing or scientific calculator to do this. Sorry, I didn't bring mine up here. I have to type, is this even going to show up? I have to, on the 83s, you have to type the number first. So I'm going to type 8, you hit math. You're going to go to the probability menu when you get in there, bless you, and pick the combination. So that's the third one down. You hit enter, and then you have to enter how many of the total that you want to choose. So we want to choose 3, and then it'll tell you the number of omelets you can make, which for this question should be 56. Number 66, this is just a little foil. I just want to remind you, you cannot distribute an exponent if you have adding or subtracting inside your parentheses. So you want to write that however many times that exponent is, otherwise you'll mess up and you'll miss out on the middle term. So make sure if you're squaring something, you're multiplying it by itself, so just write it twice. And then this can be a little practice with radicals too. You can always multiply together, but you can only add or subtract radicals if they have the same thing underneath. So just plain numbers here, 4 times 4 is 16. Now, 4 times negative root 5, you would just write negative 4 roots of 5. And you're going to turn around and get the same thing with the next 2 terms. Negative root 5 times 4, another negative 4 roots of 5. Those don't cancel. They're both negative, so that's going to give you negative 8 of those. Now, on the end, be careful. Negative times a negative should become positive. 5 times 5 would go under the square root, which is 25. So that last term actually does become a perfect square. So this would be 16 minus 4 would be minus 8 roots of 5. This term on the end is plus 5. The only other thing you could do there is combine the 16 and the 5. So my final answer here should be 21 minus 8 roots of 5. And I can't combine anything further there because the 21 does not have a radical attached to it. So don't be tempted to subtract those 2 numbers. All right. Graph the function, state the domain and range. This is a rational function. You're not shifting left or right. All right, so it's just x by itself in the bottom of that fraction. So we're not allowed to divide by 0, so x equals 0, which I know that's weird, but that's actually the y-axis. That is your vertical asymptote there. And then the 5 on the outside, it's minus 5. That scooches the graph up or down. You just copy that. So I'm going to copy a negative 5. And that'll be my horizontal asymptote. Okay, now, you got to look at the equation. If you just have a plain x, you don't see any squared or anything, the little branches are going to go diagonal from each other. So there's no squared here. So one branch, they'll be across from each other diagonally in the quadrants here. So if the number on top is positive, which is what we've got here, like if I just have y equals 2 over x, those branches go in quadrants 1 and 3. The reason for that, like if my x value is positive, right? I'm on this side of the graph. If my x value is positive, I'm doing a positive number divided by a positive number, so that makes the y value a positive number. If I plug in a negative value for x, which would be over here on the graph, you'd have a positive number divided by a negative, which would create a negative y value. So that's why the branch is down here. The asymptotes just literally shift where your quadrants are at. So for this graph, this would be quadrant 1, this would be quadrant 3. And you won't have to physically graph anything, you're just going to have to sketch it. Or you're not going to have to sketch it, you're just going to pick it out of the multiple choice. Okay. Yeah. Write this in exponential form. You don't have to do anything here. You're just going to switch this. This is a true statement. We're just going to write it in exponential form, which means I do not want to see a log. So to get rid of the log, you're just going to swing the base. The 25 is going to stay where it's at. This will also be a true statement. The base of the log becomes the base of the exponent. It's going to push that 2 up in the air. 25 equals 5 to the second power. Totally true. You're not solving anything here. You're just switching between the two different formats. Now, write a function that represents the value y after x years of a new home that's purchased for $150,000. This is going to be an exponential. The initial amount is $150,000, so that's going to be your a value. All right, now the b value depends on the question. It's either 1 plus the rate or 1 minus the rate. You have to determine that from what it says in the question. So if you buy real estate in general, that should appreciate in value, which means it increases in value. So 2 things you have to do. You have to decide, is it growth or decay? This one should be growth. So I should do 1 plus the rate. The other thing I have to do is I have to make sure I take that percentage and change it to a decimal. So don't put 0.8 because that would be 80%. Your rate here, take your percent, divide by 100, or scooch the decimal place over 2 spots. This should be 0.08. Your b value is 1 plus that. So in the little formula, it's 1.08. And then the exponent would just be x. It just tells you to write a model. It doesn't say, like, find the value of the home in 5 years or anything. So we don't have to plug anything in. We're just writing the model. If I wanted to find the value of a home after, 10 years or whatever, then we could plug that number in for x. It doesn't ask you to do that here, and it doesn't ask you to do that on the test either. All right, half-life, similar, but just a hair change to the formula. In a half-life formula, you know the b value is 0.5 because it's how long it takes the substance to decay 50%. So it'd be 1 minus 0.5, which would be 0.5. The other thing that's just slightly different, the exponent, x is time here, it's x over the half-life. And so it's going to be a little fraction as your exponent. Okay, so the half-life of the substance, it says, is 18 days. The initial amount that's going to be your a value is 300 milligrams. Write a function that models the decay of the substance. Use your equation to find how much the substance remains after 30 days. Okay, so just a general function. We're starting out with 300 milligrams, a half, because we're doing half-life. It would be x over 18 would be a general function for that. If you want to find out how much remains after 30 days, all you're going to do is sub in 30 for x and just grab your calculator. So we're doing 300 times 0.5. And then here's what I would, like I have an 83 up here right now. I would put parentheses around that exponent if you can't see that it's all in the exponent, because you don't want to do like to the 30th power and then divide the whole thing by 18. So make sure either figure out what that is or just put that in parentheses. So we should have, what are we supposed to round to? Ooh, it doesn't say. All right, so let's say, I don't know, we'll say about 94.5 milligrams is what we would have left. Now, the last 3 are very super similar to the ones on the actual test because these are multiple choice. Okay, it says identify the sampling method. Oh, fail. Sorry, these are spelled. This should be systematic. I didn't notice that till just a second. This is spelled wrong. And I just started to spell. Systematic is what the 3rd choice should be. Okay, I don't know why it says systemic. Anyway, identify the sampling method. Research group selects every 5th person on a list of registered voters in the state to call about their intentions to vote in the next election. Do you remember what kind this is? Which one of the 4 methods that we talked about? Remember? Oh, you guys just said it. Yes, this is the systematic, the one I totally spelled wrong. It's like every 10th person, every 5th person, every 3rd person, whatever. If it's every so many people or objects or whatever you're trying to collect data from, it's systematic. This one, same question, but different scenario. It says the editor of a skateboarding magazine wants to find the reader's favorite places to skateboard. The latest edition of the magazine included a survey card, and 429 readers completed the survey and returned the card. What kind is this one? Self-select, because you're choosing to respond to this and you're mailing in your little survey card. Okay, now this last one's kind of a... It's one question about this box plot. Okay, so box plot shows data about the hat sizes of 2 different baseball teams. So you got your Sharks and your Seals, apparently, and we're comparing them for the sizes of their hats. This says, which statement is best supported by the information in the box plots? Okay, so median hat size for the Sharks. So your median, I'm going to just label this real quick. The median would be in the middle, not necessarily the direct middle, but inside the box and whiskers. It's inside the boxes. So I'm just going to, median and Q2 are the same thing. So for those 2 boxes, it would be the line. So it says the median hat size for the Sharks, that's the top one, is less than the median for the Seals. Definitely not, because this one's smaller. All right, the median hat size for both teams is the same. No. The interquartile range of hat sizes for both teams is the same. I'd have to kind of figure this out real quick. So your IQR is Q3 minus Q1. So for this team at the top, it would be this line, which looks like it's 7.5, minus this line, which would be 6.5. So their interquartile range would be 1. This one, it looks like 7.25, and this one looks like 6.25. So that is true. I'm just going to check the last one. The interquartile range of hat sizes for the Sharks, nope, they're the same. So letter C should be your answer for this last question. Okay.